Hi guys, myself Nishad. I am here to discuss about the range of trigonometric functions. How to find the range of trigonometric functions. Consider the examples. Sin square x, root sin x, 4 tan x cos x, cos raised to 4x minus sin raised to 4x, tan square of pi by 4 minus x, sin square pi by 8 minus 4x, cos of sin 2x, cos of 2 sin x, cos of 4 sin x, etc. These all questions coming under type 1. We want to find the range of all these trigonometric functions. Basically, there are 6 types of trigonometric functions, or we can use 6 methods to find the range of trigonometric function. All these are under type 1. In type 1, we are using the concept of boundedness of trigonometric functions. Okay, the boundedness means we know that the value of sin x is lies between minus 1 and 1. That is a bounded function. And the value of cos x is also bounded in between minus 1 and plus 1. And tan x is not a bounded function. This value is from minus infinity to plus infinity. For sin x, we know that minus 1 less than or equal to sin x less than or equal to 1. That means it is bounded in between minus 1 and 1. That is sin x belongs to minus 1, 1 closed interval. Okay. And similarly, for a cosine function is also bounded in this interval. That is minus 1 less than or equal to cos x less than or equal to 1. In the case of a tangent function, that is an unbounded function. That means minus infinity less than tan x less than. This implies cos x belongs to closed interval minus 1, 1. And this implies tan x belongs to open interval minus infinity to plus infinity. Okay. Now we know that the graph of sin x is like this. The maximum value of sin x is 1 and the minimum value is minus 1. This is a top value and this is a bottom value. So the value of sin x is lies between minus 1 to 1. This is the graph y is equal to sin x. In the case of a cosine function, we know that the graph of the cosine function, okay, and the maximum value is 1 and the minimum value is minus 1. This is y is equal to cos x. So the value of y is bounded between minus 1 and 1. In the case of a tangent function, the graph will like this. This is at pi by 2 and this value is at minus pi by 2. This is equal to y is equal to tan x. And when x is approaching pi by 2, the value of the function goes to plus infinity. When x is approaching minus pi by 2, the graph is going to minus infinity. That is not a bounded function. So value of y is from minus infinity to plus infinity. Right. Now, what's the value of x? At this point, value of x 0. This is a point where pi. This is 2 pi. This point is pi by 2. The sin x has maximum value 1. And 3 pi by 2. This point is minus pi by 2, minus pi, and so on. And pi by 2 means approximately equal to 1.57. And the value of pi, that is this value, is approximately equal to 3.14. And 3 pi by 2 approximately equal to 4.71 and so on. This value of x is minus 1.57 minus 3.14. Now suppose there is any change in the argument, that is a value of x, is it will affect the bounds, the value of minus 1 and 1. Now you consider sine 2x. What is the range of sine 2x? That is, any change in this argument does not affect the range. That means sine 2x is also lies in between minus 1 and 1. And similarly, sine x by 2. So argument is divided by 2. That is also coming under minus 1 and 1. This is true in the case of cosine function, tangent function, etc. So change in argument does not affect the value of range. For example, sine of pi by 4 plus 2x. Then also the range is same. That is from minus 1 and 1. Suppose our function is 2 sin x. Then what is the value of its range? That means here sin x is multiplied by 2. So minus 2 less than or equal to 2 sin x less than or equal to. Now the range of belongs to minus 2 and 2. But change in the argument does not affect the range. But the sin x is multiplied by another constant, then the range will change. This is applicable for all trigonometric functions. Okay, now let us do these problems. Consider our first question, that is y is equal to sine square x. Okay, since we know that the value of sine x belongs to minus 1 and 1. That is minus 1 less than or equal to sine x less than or equal to 1. Now squaring this term, that becomes sine square x is always greater than or equal to 0. So the value of the range, so the range of sine square x is greater than or equal to 0 and less than or equal to 1. So the square of a function never become negative. Square is always a positive quantity. That means 0 less than or equal to sine square x less than or equal to 1. So the range of sine square x belongs to 0 and 1. The graph of the sine square x, the graph of sine x is like this, and this become, this is a graph, this is a graph of sine x, and the red line represents the graph of sine square x. Since sine square x is always positive, the minimum value is 0 and the maximum value is 1. So the range is 0 to 1. Okay. Second question, that is y is equal to square root of sin x. Since square root is a positive quantity, so the term, this term inside the square root should be positive. That means square root is a positive quantity. So the value of sin x should be positive inside the square root, since this is a real valued function. So 0 less than or equal to square root of sin x less than or equal to 1. So root of sin x belongs to closed interval 0 and 1. So this is the range of this function. Consider the third example, that is y is equal to 4 tan x cos x. Right. You can write this is equal to 4 into tan x is equal to sin x by cos x. Sin x by cos x into cos x. This is equal to 4 sin x. This can get cancelled. So the range of 4 sin x is from minus 4 to plus 4. Since minus 1 less than or equal to sin x less than or equal to 1. Now multiplied by 4, you get 4 sin x less than or equal to 4. And minus 4 less than or equal to 4 sin x less than or equal to 4. So range of 4 sin x belongs to minus 4 to 4. Now consider this cancellation. Cos x and cos x get cancelled. When x is equal to pi by 2, cos x become cos 90, that is 0. This becomes 0 by 0. So we can cancel. And similarly, for any odd multiple of pi by 2, that is 3 pi by 2, 5 pi by 2, or in general 2n plus 1 pi by 2, cosine of 2n plus 1 pi by 2 is equal to 0. So this cancellation is not possible. So we can draw the graph of 4 tan x cos x, that is equal to 4 sin x, like this is the value of the function at pi by 2, 3 pi by 2, 5 pi by 2, this is minus pi by 2, minus 3 pi by 2, and so on. And odd multiple of pi by 2, this value of cos x become 0. So 0 by 0, 0 by 0 we can cancel. So there is always a discontinuity at this point. That is an odd multiple of pi by 2. So this is the graph for this maximum value is 4 and minimum value is minus 4. And this is discontinuous at odd multiple of pi by 2. So this is the graph of 4 tan x cos x, that is equal to 4 sin x. The function is discontinuous at odd multiple of pi by 2, and the value of this function, that is varies from minus 4 to 4. This is the range, this height, minus 4 to 4 is the height of this function, but this function is discontinuous at pi by 2. Consider another example. Y is equal to sin x into cosec x, or 4 sin x into cosec x. What is the range of this function? We know that cosec x is equal to 1 by sin x. So y can be written as y is equal to 4 sin x into 1 by sin x. That is equal to 4. Okay. When x is equal to pi, 2 pi, 3 pi, or multiple of pi, what is the value of sin x? That is sin pi is equal to 0, or sin n pi is equal to 0. So a 0 terms coming in the numerator and denominator, 0 by 0 form. So this function is always discontinuous at the multiple of pi. So we can draw the graph of 4 sin x cosec x like this, and at the value of 0, pi, 2 pi, 3 pi, minus 2 pi, etc., the function become discontinuous. So we can mark at value, this is the value of y is equal to 4 sin x cosec x, that is equal to 4, and this function is discontinuous at x is equal to 0, x is equal to pi, x is equal to 2 pi, 3 pi, minus 2 pi, etc. So this is the graph of this trigonometric function. Our fourth example, that is y is equal to cos raised to 4x minus sin raised to 4x. We can write this expression is equal to cos square x minus sin square x into cos square x plus sin square x. The value of cos square x plus sin square x is equal to 1. So this is equal to cos square x minus sin square x, that is equal to cos 2x. So the range of cos 2x is from minus 1 to 1. Since cos x belongs to minus 1 and 1, and cos 2x is also belongs to minus 1 and 1, since changing the argument do not affect the value of range. So the range of these functions belongs to minus 1 to 1. Okay, consider the fifth example, that is y is equal to tan square pi by 4 minus x. Okay, and we know that the value of tan pi by 4 minus x, that is minus infinity less than tan x less than plus infinity, and change in the argument, that is x is replaced by pi by 4 minus x, that should not affect the range. So tan pi by 4 minus x less than infinity and minus infinity less than tan pi by 4 minus x less than infinity. Okay, now squaring, that is tan square x is always greater than or equal to 0. Similarly, tan square pi by 4 minus x, that is a positive quantity, is always greater than 0. So the range of tan square pi by 4 minus x is in between 0 and infinity. That is 0 is included. When x is equal to pi by 4, tan square pi by 4 minus x is equal to 0. And this is less than infinity. So the function belongs to closed interval 0 and to open interval infinity. That is the range of this function. Our sixth question is sine square 15 by 8 minus 4x. That is sine y is equal to sine square 15 pi by 8 minus 4x. Since we know that the value of sine of this argument lies between minus 1 and 1. So the value of sine square of this argument lies between 0 to 1. This belongs to closed interval 0 to 1. Since square of a function is always positive. Okay. Y is equal to sine square 15 pi by 8 minus 4x minus sine square 17 pi by 8 minus 4x. So this question is in the form y is equal to sine square a minus sine square b, and using the identity sine square a minus sine square b, that is equal to sine a plus b into sine a minus b. This is equal to sine a plus b into sine a minus b. That is the identity. So we can write this as y is equal to sine of this argument plus this argument, that is become pi by 8 pi 15 pi by 8 plus 17 pi by 8, that is equal to 32 pi by 8 minus 8x into sine a minus b, that is 15 pi by 8 minus 17 pi by 8, that is minus 2 pi by 8. Okay, now this is equal to sine 4 pi minus 8x into sine of minus pi by 4. Sine 4 pi minus 8 is equal to minus sine 8x, that is minus sine 8x into sine of minus pi by 4, that is minus 1 by root 2. So this is equal to 1 by root 2 into sine 8x. And we know that the value of sine 8x belongs to minus 1 less than or equal to sine 8x less than or equal to 1. So 1 by root 2 into sine 8x means we are multiplying here by 1 by root 2, here also by 1 by root 2 and 1 by root 2. So that means the range of this function is from belongs to minus 1 by root 2 to 1 by root 2. So the range of this function belongs to closed interval minus 1 by root 2 to 1 by root 2. Consider the function y is equal to cos of sin x. That is, y is equal to cos of sin x. We want to find the range of this function. And we know that the value of sin x, that belongs to minus 1 and 1. That is minus 1 less than or equal to sin x less than or equal to 1. So this value of the function y is equal to, the minimum value is of this argument of cosine is minus 1 and maximum value is 1. Okay, cos of minus 1 and cos of 1. And we know that cos of minus theta is equal to cos theta. So cos of minus 1 is equal to cos 1. find the range of phi. Let us draw the graph of cosine function. This is the graph of a cosine function, right? And y is equal to cos of x, right? 0, pi by 2, pi, 3 pi by 2. This is again minus pi by 2, minus pi, minus 3 pi by 2, and so on. The value of pi by 2 is equal to 1.57 approximately. That is, the value is 1.57. And value of pi, we know that it is equal to 3.14. And the value of 3 pi by 2 is approximately equal to 4.71. Okay, now again here this value is minus 1.57. This point is minus 3.14 and so on. So minus 1 is a point coming here. This is minus 1. And plus 1 is this point, plus 1. Okay, so cos of 1, the value of cos of 1 is this point. This is cos of 1. And cos of minus 1 is this value, cos of minus 1. That is, cos of minus 1 is equal to cos 1. So the value of this function is from cos minus 1 to cos 1. That is, cos minus 1 to cos 1. This portion of the graph. So this is the graph of our function y is equal to cos sin x. That is marked in red. So maximum value of this function is 1. That is that sin of x is equal to 0. This one value. And minimum value is equal to cos 1 at this point. This is the minimum value and this is the maximum value. So this function belongs to cos 1, closed interval, close 1, and the maximum value is 1 to 1. So range of y is equal to cos sin x is cos 1 to 1. Okay, second example, that is y is equal to cos of 2 sin x. And we know that the value of 2 sin x is in between minus 2 and plus 2. That is, minus 2 less than or equal to 2 sin x less than or equal to 2. Cos of minus 2 to cos 2. Cos of minus 2 is again cos 2. Okay, now let us draw the graph of cosine function. The graph of cosine function. Okay, this is y is equal to cos x. This is 0. This value is pi by 2. This value is pi, 3 pi by 2. Again minus pi by 2, minus pi, minus 3 pi by 2. And pi by 2 means this is equal to 1.57. Pi 3.14. And this value is equal to 4.71. Similarly, minus 1.57, minus 3.14. And this point is minus 4.7. So this is 1.57. So we can mark 2. We can mark a value 2. That is in between pi by 2 and pi. So the value of this is a point where cos 2. And we can mark minus 2 in between minus pi and minus pi by 2. This is minus 2. So the value of this function is cos of minus 2. So the graph of y is equal to cos 2 sin x is from cos of minus 2 at this point to this point. So we can mark this as, this is the graph of y is equal to cos sin x. The maximum value of this graph is 1 and minimum value is at cos 2. Cos 2. So the range belongs, the function belongs to cos 2 to 1. So the range of this function is, the minimum value is cos 2. That is equal to cos of minus 2. Cos 2, and the maximum value is 1 when 2 sin x is equal to 0. Okay. The last question, that is y is equal to cosine of 4 sin x. The value of 4 sin x belongs to minus 4 to 4. That is minus 4 less than or equal to 4 sin x less than or equal to 4. Now, when x, and this value is equal to minus 4, y is equal to cos of minus 4. And y, when this is equal to 4, this value of y is equal to cos 4. Now we draw the graph of cos x. This is a graph of cos x. Y is equal to cos x. 0, pi by 2, pi, 3 pi by 2. This is a point minus pi by 2, minus pi, minus 3 pi by 2. And value is 1.57. This value is 3.14. This value is 4.71. Okay. And again, this value is minus 1.57, minus 3.14, minus 4.7. Okay. So, the value of cos of 4. 4 is in between pi and 3 pi by 2. Just this point is marked as 4. So, the value of function is cos 4. And cos of minus 4, that is in between minus pi and minus 3 pi by 2. That is, this is minus 4. So, the value, this is the value of cos of minus 4. Now, the function is between cos minus 4 and cos 4. So, from this point to this point. So, this is the graph, this portion. So, the maximum value of this function is 1. And minimum value of the function is minus 1. This is the maximum value and this is minus 1. Since cos 4 is greater than minus 1, this is the value of cos 4, that is equal to cos of minus 4. So, the value of y in between minus 1 and 1. This is the minimum value and 1 is the maximum value. So, this belongs to minus 1 and 1. Okay. In next class, we will discuss about type 2 trigonometric function for finding the range of type 2 trigonometric functions. Okay, bye.